Good morning, students. So we'll move on to the next topic, that is interrupt. Fine. So the name only indicates interrupt stand for some kind of a disturbance. Fine. So now the task is we need to disturb the working of processor. Fine. When we are considering all the functional units or the devices, whatever we are using, which are all connected to our motherboard, everyone will be having their own priority level. Remember this. Keyboard is having its own priority. Mouse will be having its own priority. Like input device will be having certain kind of a priority. Output device will be having certain kind of a priority. Likewise, in case of memories also, like primary memory will be having highest priority compared to the secondary memories over here. Fine. So now feel that your processor is busy with providing a service for the highest priority devices over here. Fine. And now the lowest priority devices, they are expecting some service over here. So the general working principle is like after providing the service for the highest priority devices, processor will start providing the service for the lowest priority devices over there. Clear? So in between, if any lowest priority device or any device, it is not compulsory. I'm just taking an example of highest priority and lowest priority. Okay. In case of like these kind of lowest priority devices, if they would like to get a service from a processor, okay, then they are raising a hardware signal. Okay, to the result of that, okay, processor will pause the execution of that previously started service regarding the highest priority, okay, and it will start providing the service for the lowest priority devices over here. Okay, the main meaning of this explanation is like whenever a device is expecting any kind of a service from a processor, he must raise a signal. We are calling it as interrupt. Okay, so when the processor receive a interrupt signal from any particular device, okay, so it will pause the execution of present working task, fine, and it will start providing a service for the interrupted devices over there. Fine. So here also, like we are deciding which interrupt request should be provided service first. Okay, regarding that we will discuss in further topics and all. Okay, but for time being, you just feel that okay, interrupt means what? Some sort of hardware signal the devices is generating towards the processor so that they can grab the concentration of processor towards them. Fine. Okay. This is what the main motto of using interrupt request. Okay. But here, first point, just observe problem of processor entering infinite waiting loop causes reduce in the processor performance. Okay. What exactly it is? Regarding what this point is pointing for exactly. Okay. See, this point is totally dependent on IO operations. Remember this. Fine. Okay. So whenever we are typing, fine, while explaining the input output operation, okay, we are using data in buffer. Is it right? For what purpose we are using that data in register over there? Because the typing speed of the user and the working speed of the processor will be, if you are comparing, there is a huge gap over there. Okay. So if processors start waiting for the user input, then he'll be lagging with some other task which should be performed. Okay, then automatically the processor working capacity or efficiency will be reduced over there. Fine. So if the processor is keep on waiting for the user input, then obviously it will be entering for an infinite waiting loop. Remember this. Okay. So to avoid that, what we can do is whenever data is available or whenever user is entering the input, okay, then there should be some indication to the processor that yes, some input is entered by the user. Yeah. Okay. Because of that, what alternative we are using over here? S in and S out. You remember S in is a flag. Okay. If S in is set to 1, it states that what? Yes, there is some data available inside a data in register over there. Then obviously the processor will come to that particular location, which one, like it will send some signal, okay, like a read signal towards the data in buffer. Okay, so the content of data in will be uploaded to the data line. Finally, data will be received by the processor exactly. Okay, so if you are skipping this SIN procedure, okay, then like how your procedure will come to know like yes, there is some data available in a data in. Okay, he should be start waiting from like starting from 0 to till he receive the input over there, right? Okay, like the number of seconds will be more, waiting time will be more over there. Okay, so what we need to do, we need to have some alternate principle, okay, so that whenever data is available, there should be some kind of a indication towards the processor, okay, because of that he will start responding. Clear? Okay, that is what the first point states exactly. Okay, so these are the few interrupt cases what we discussed up to now. Okay, S in and S out, okay, is the only interrupt concept we discussed up to now. Because of that, I am highlighting it now. Okay, fine. So then, next point, second point. It can be avoided, that infinite loop, entering of infinite loop can be avoided by sending a hardware signal by a device called interrupt. Okay, so whenever the device is available with some data, or if output device is ready to display the content and all, okay, what they can do, he can just directly send an interrupt request for a processor over there. Okay, that is what hardware signal we call it as. Okay, one of the bus control line is dedicated to this purpose called interrupt request line. Okay, you may ask like how we are having control data and address line. Okay, like that we are having one dedicated line for sending an interrupt request from devices. Okay, so in like up to now we were discussing like the bus cable is consisting of only three section, that is for address, control and data. Okay, but apart from that we are having many other section. In while discussing single bus structure, I already discussed about that. Okay, here we are discussing like apart from that, those three, okay, we are discussing one more line, okay, that we are calling it as what, interrupt request line. So whenever all devices, remember, it is not like individual line for individual devices. No, it is a common line. Remember, it is a common line. Okay, so all the devices which are all connected to the bus cable, they are also connected to the interrupt request line. Remember this. Okay, so if the devices want to transfer any kind of interrupt request, they will start activating this particular line. Then from using this particular line, your processor will be receiving the interrupt request over there. Okay, we are having some hardware requirement or hardware setup for this. Okay, next slide you will be getting about it. Okay, so interrupt request line. Okay, we will be having a dedicated line for sending an interrupt request over there. Okay, fine. Later, same point, until processor gets signal from this line, processor won't respond. Okay, so whenever processor is receiving a interrupt request from this particular line, then only your processor will respond, otherwise he will not. Remember this. The routine executed in response to an interrupt request is called interrupt service routine. Okay, so your input device may be expecting some service from the processor. Okay, because of that he will raise an interrupt request. Okay, to the response of that interrupt request, remember, to the response of that interrupt request, whatever, okay, whatever action will be taken by the processor, that we are calling it as what, interrupt service routine. Okay, device is expecting the service which is activated by the processor, the same service. Okay, we are calling it as what, interrupt service routine. Exactly. Okay, fine. Then later, whenever the processor receive an interrupt request, it should be acknowledged to the device that your request has received successfully. Okay, for that we are having another special dedicated line. Okay, how we are having interrupt request line, like that acknowledgement line also we have in the bus. Okay, so interrupt acknowledgement line signal for confirming to this, for confirmation to the sending device. Exactly. Okay, otherwise there is a huge big problem if you are skipping this acknowledgement. Okay, then there will be a big problem. Okay, what problem it is, I will explain in the third slide. Okay, fine. The time between generation of interrupt requests and beginning of interrupt service routine is called interrupt latency. I think that interrupt latency last line is not visible exactly. Okay, the time between generation of interrupt request and beginning of interrupt service routine is called interrupt latency. Exactly. Latency stands for what? Duration. Okay, or delay, what we call it as. Feel that sharp 10 a.m. Your monitor is raising an interrupt request towards the processor. Sharp 10 o'clock. Okay, no 9 o'clock, 10 o'clock it will. Okay, so like to feel that, like from monitor to processor, for sending that interrupt request, 1 second we need. Okay, then later processor will acknowledge that particular request, that your request has been received by the processor. Okay, so because of that, like for the acknowledgement, we may be getting like one second delay over there. Okay, so first second for sending the interrupt request. Okay, that second one will be for acknowledgement, so total 2 seconds over. Okay, then later feel that like processor need to provide service for that particular monitor, okay, for that we need 3 seconds, total 5 seconds. Okay, so beginning at 10, okay, and the service we are completing or the routine we are completing at 10, 5 seconds. Okay, so the latency will be what? Total 5 seconds. Okay, like when you are initiating the interrupt request, okay, till you are getting the complete service, end of the complete service, okay, whatever the duration we are having, we are calling it as latency exactly. Okay, so these are very, very important points: interrupt request line, interrupt latency, interrupt service routine, interrupt acknowledgement. Okay, they may ask for 1 marks, like 5 marks question, it may be what is interrupt, comma, interrupt request line, comma, interrupt service routine, comma, interrupt acknowledgement, and interrupt latency. Be careful, students. Okay, so now, so this is what the hardware setup, and we are calling it as open drain or open collector. Okay, this setup, like interrupt hardware, we are calling it as interrupt hardware. Okay, so these two word is very, very important: open drain or open collector. Okay, what is this open drain or open collector? See the box what we are having, right? Okay, so this we are calling it as open drain or open collector. This hardware, okay, we are designing using this open collector, so we can also name this figure as what? Open drain or open collector structure for interrupt hardware. Okay, or simply we can in your exam they may ask like interrupt hardware, explain interrupt hardware with a neat figure. Okay, then this figure is compulsory along with like further discussion and all whatever we are going. Okay, like you need to explain how this circuit is going to work. Okay, so now this circuit is explaining like if any device want to raise an interrupt request, how that request will be generated and how it will be transferred to the processor. Yeah, I hope you don't have doubt from the previous slide. So this is what the figure which will explain like how to generate an interrupt request first thing, and how this request will be traveling towards the processor. Okay, those things, only those things. Okay, fine. So here you just observe, here we are having a processor. Fine. Okay, so here we are having one NOT gate. Fine. So here you will be having a interrupt request line. For that, each and every devices are connected. Fine, each and every devices are connected. Okay, so you can observe we have something called as VDD. So this is what the voltage, okay, or the like the power which will be continuously flowing towards the processor. Okay, so VDD will be equal to 1. Remember, VDD initially it will be equal to 1. Okay, so what is the flow we are having over here? 1 exactly. Observe it carefully. Observe it carefully. If the voltage level in this particular line is equal to 1, we are having a NOT gate over here, right? Complement of that will be received by your processor exactly. Okay, whatever voltage we are having over here, complement of that will be received by your processor exactly. Why? Because we are having a NOT gate. If it is 1, okay, here you are going to get 0 over here. You may ask when it will be 1 exactly. Okay, see, these are all the devices. Okay, INTR1, INTR2, INTRN we are having, right? So these are all devices. Observe it carefully, and this box we are calling it as open drain or open collector. Okay, so this particular like forward slash kind of line what you can observe, this we are calling it as latch. This we are calling it as latch. Okay, so here actually devices are connected. Okay, these are all what the devices. Okay, they are connecting to this interrupt request line through a device we are calling it as what? Open drain or open collector. Okay, so why we are calling it as open? Because it will be by default open always, remember. So whenever the device which is connected to the interrupt request line through this open collector or open drain, okay, want to raise an interrupt request line, then this latch should be made close. Okay, I repeat, these are the devices, okay, which are all connected and they are grounded also. Okay, fine, there is a option of ground, remember. Fine, so this will be always open, right? See, each and every device is like latch will be open exactly. Now if this particular device want to raise an interrupt request line, what he should do? He should close this latch. If we close, observe it, we are having a direct connection to the ground. Previously it was, we are having a breakage of connection, right? We didn't had a connection continuous, okay, between ground and this interrupt request line. So here, what is the voltage we are flowing? Okay, we are flowing with 1 exactly. Okay, now if you are connecting this circuit, if you are completing this circuit, this 1 will start flowing to the ground, and the voltage level in this particular line will be dropped to 0. Why? 1 it was, it will be grounded, so 1 will be changed to 0 exactly. Now 0 is received by the processor exactly. Okay, so here what you have, NOT gate you are having. Because of that, we need to make a complement, and here in the interrupt request line you will be getting 1 exactly. This indicates yes, some device is raising an interrupt request. Yeah, okay, fine. Now you may be having doubt like, okay, so this is what the first device, second device, and third device. Okay, see, okay, we are using a common line, right? We are using a, let me clear the screen. Okay, we are using a common line. Okay, one is the voltage over here. Okay, so meanwhile we are having 0 over here. Okay, one is the voltage we are having. So if this device is closing the latch, then VDD will be equal to 0. Complement of 0 will be 1, INTR will become 1, and processor will come to null. Like yes, some device is raising an interrupt request. But if both the devices are trying to raise an interrupt request, then how processor will come to know like two devices are raising an interrupt request? Okay, so this we will discuss under the topic called as handling multiple devices. Okay, under interrupt topic itself. Okay, handling multiple devices. Okay, we are having scenarios like, okay, if simultaneous interrupt request comes, okay, then how to deal with multiple devices. If they raise an interrupt request, then how to deal with them? Okay, there are a lot of discussion under interrupt topics. Okay, don't worry about that, but just try to understand the circuit working. Okay, VDD will be equal to 1. Okay, so here we are using a register R. Okay, so always it will be equal to 1. Okay, when the drain is open exactly, or else collector is open exactly. If any device want to raise an interrupt request, they need to just close this latch, then the voltage will get dropped to 0. Okay, complement of 0 will be 1, then processor will come to know like, yes, some device is raising an interrupt request. Okay, so I hope you don't have doubt in this particular circuit. Okay, so we'll go for next case exactly. So this is what the interrupt hardware, remember. Okay, so now enabling and disabling interrupt. Okay, okay, fine. So we'll go for one example. Example of interrupt request from printer after printing all the lines. Feel that we're having a PDF or MS Office file, okay, which is consisting of total 1000 lines. Okay, so user want to print the content, so he will go for a file option, then go for print. Okay, then automatically printer will start receiving the content from the system. Okay, finally it will complete the printing procedure. Okay, so now after printing, observe it carefully, after printing all those 1000 line, printer will raise an interrupt request towards the system that yes, I am ready to display the content, or else I'm ready to print the another line, or else like a group of lines. 1000 line already printed. Now it is ready. It is having the ability to print any number of lines over there. So what he will do, if he is ready to print the content, he will just raise an interrupt request towards the processor that okay, send some information so that I can print it. Okay, so now what processor should do is he should respond to that printer that I am not available with any kind of information to get printed over there. Okay, so for this communication back from processor to the printer will trouble the procedure performance over there. Okay, so now what we need to do is we need to have some option that after providing some service for a device or after providing a service for a printer, okay, we should have the option of enabling and disabling. Okay, means processor if enable that particular device, then he can raise an interrupt request. Okay, otherwise he can disable. Okay, that option should be available. Otherwise, the devices after providing the service or after completing their job, they will be keep on updating the processor that they are free. Okay, like by setting SN is equal to 1 or S out is equal to 1. Okay, that indicates the interrupt towards the processor exactly. They are ready to display the content, right? Okay, so this kind of problem will lead to the drastic decrease in the processor performance only, because continuously processor should respond to them and it should know that, like it should let them know that like there is no content available to print over there. So we can avoid that by using a signal called as enabling and disabling. Okay, by processor to devices exactly. Okay, so that is what the first example of interrupt request from printer after printing all the lines. Okay, so this may reduce the processor performance. Okay, cause processor because processor should respond that no lines are available to print over. Okay, so this will harm the processor performance exactly. Okay, fine. We'll see that. Other than this, what are the cases we are going to face over here? Okay, when device initiate interrupt request, they will wait for few seconds. Remember. Okay, so whenever devices are raising an interrupt request, they will wait for few duration. Like they will be waiting. Like yes, we will get a service from the processor. There will be waiting time. Remember, 5 seconds, 10 seconds. Consider like 5 seconds. Okay, observe it. Consider like 5 seconds. That is what the waiting time. Okay, if they get service back, interrupt request line will be deactivated. Okay, before expiring that waiting time 5 seconds. Okay, if processor give a response to that interrupt request line, then the interrupt request will be deactivated by that processor, by that device exactly. Okay, it will just remove that particular interrupt request from the interrupt request line over. Okay, but if not, okay, like if processor is busy with some other task and if he is not, if he is unable to provide a service for that particular interrupt request, okay, then waiting time of that interrupt request get expire exactly. Okay, so that's why last sentence states, okay, else some device generate another request for same task. Okay, else same device generate another request for the same task. If that waiting time expires, the device will feel that the request which has been sent to the processor, okay, has not received by the processor. Because of that, the device will raise an another interrupt request for the same task. Remember, for the same task, it will raise second request. Okay, see, processor is busy with some other task. He has not provided a service for the first task, right? First task is pending. Okay, or first request is pending. Later, due to the expiry of the interrupt request waiting time, okay, the device has raised second request for the same task. Now, how many requests are available? Two requests are available. Okay, so that is what the third point states. So now there are two interrupt requests in queue. While serving the first request, observe it carefully. While serving the first request, waiting time of second request expires. Is it or not? Okay, because the waiting time of the interrupt request is total 5 seconds. Now, if processor start providing a service for the first interrupt request of the device, okay, then second will be in waiting loop, right? The waiting time of the second get expired. Then what device will do? Second time what it which has been sent by the device, it has not received by the processor. It will be feeling like that. Okay, so what he will do? He will raise the third one for the same task, feeling that request has not received by the processor. Okay, now you are providing a service for the first, but in the back end you are pending with two more requests of the same task as well. Okay, which lead to a queue of same request, causing processor to enter infinite loop. Okay, just observe it carefully. While providing the service for the one, third get generated. While providing the service for the second one, fourth will get generated. Means your processor will be continuously busy with providing a service for only one request. Okay, same task, multiple requests. That's it. Clear? Okay, so what we need to do? We need to avoid this. How? Once, if device is generating any input request or else any kind of a interrupt request, okay, we need to disable that device so that he cannot raise an interrupt request for the same problem. Remember, for the same task, he cannot raise an interrupt request. But for other tasks, yes, he can. Okay, that's why we are having the option of what enable and disable. How we can do this? Observe it. Fifth point. To avoid this, after generating the one request, device will be disabled. Okay, so that he cannot raise another request for same task. Okay, fine. Once we are done with disabling, okay, then processor will start providing the service for that particular request. After providing the service for that particular request, after completion of everything, okay, the processor will enable that device. Okay, so later if anything is available, okay, like regarding the same task, okay, may be available, right? Okay, any other problem may be available or any other issue may be available. After enabling only, that device can raise an interrupt request for the same task. Okay, this will avoid, remember, this will avoid what? Processor to enter infinite loop. Okay, that's why the last point states, after serving one request, device will be enabled so that he can raise interrupt request about same task again. But if anything is available, if any, available, then only he can rise for the same task. Otherwise, he will generate for the other task. So this will avoid the processor to enter infinite loop. Enabling and disabling concept, very, very important, students. Okay, fine. So later, uh, we are having some like procedure how interrupt is working, flowing, like how it will be followed or how it will be flowing over there. You will see this. The device rises an interrupt request. Fine. The processor interrupts the program currently being executed. Means whenever device is raising an interrupt request, then processor will just like pause the execution of currently handled task exactly, and it will be concentrating on interrupted request over there. Okay. The processor interrupts the program currently being executed. Okay, interrupts are disabled by changing the control bits in the processor status register. Okay, the devices is informed that its request has been recognized, and in response, it deactivates the interrupt request line or interrupt request signal exactly. The action required by the interrupt is performed by the interrupt service routine. Okay, interrupts are enabled and execution of the interrupted program is resumed. Okay, so presently on what processor is working for, that should be paused first. Later, processor should perform the execution, or else it should execute the service for the interrupt request exactly. Okay, then also it should be intimated that signal has been received by using an acknowledgement line. Later, we need to disable the interrupt request. Okay, later, after providing the service, we need to enable it. Yeah, so this is it for now, students. So this is the topic of interrupt, basic topic of interrupt. So we are still remained with few more topics regarding the interrupt that we will discuss in next class. Thank you, students.